So let's jump into the software development sort of cycle, the way that we engineer software. With software, there are a bunch of different ways that you can do it, and these are usually called models, and that's how you actually implement these sort of 5 steps. However, these 5 steps are usually crucial to getting a piece of software up to standards that are, very reliable. With this, you'll also notice that these can be applied to really any engineering practices. Like in the last lecture when I talked about building a bridge, this could be sort of used for that as well. We would go over requirements and design and implementation and verification and maintenance all with a bridge. So if we want to think about it like that, as we go through this, it might make it stick a little bit better. The first thing we want to talk about is we want to talk about something called requirements. So the requirements are pretty simple. The requirements are, what are we building? So the requirements are the what. What are we going to build? We want to be able to get that to a point where no one will be able to contend what we're building. What I mean by that is we don't want a group of 8 people building this, all with a different idea of what the end product is going to be. We don't want them thinking that, maybe one person thinks that it's going to use 8 servers. One thinks that it's just going to be a local server. One thinks that it's going to be a business run, it's going to be used mainly by business people, while someone else thinks it's going to be used mainly by consumers. That would be a big problem if you're trying to get a whole bunch of people to work together on a project. Everyone would build in a different direction and it would fall apart. So with the requirements, what we're trying to get is the what. What are we building? And there's a whole bunch of different little steps in each one of these, and that's what sort of this entire course is going to be about, is jumping into these. So this is just a top-down view, and then we're going to do a deep dive a little bit later. So anyway, requirements is first. Second is design. Design is the how. So how are we going to build it? What are we going to use? What sort of technologies are we going to put together? How is the server going to be set up? How is the front end going to be set up? Should the front end do this or that? That's where design comes in. And design is very important. A lot of people skip this step. A lot of people will do the requirements. They'll do requirements, but then they won't actually go down to design. They'll just sort of jump straight into implementation. So, they'll be like, okay, we kind of have a good idea of what we want to build. Let's jump into implementation. And that can be dangerous because, again, there are still some variables out here and there's still some things that we want to make sure work before we implement them. Because, for example, let's say that you built an 8-server giant masterpiece, or at least you think it's a masterpiece. And then when you click, the play button, you finally get it running, you realize, oh, this doesn't work with 8 servers. It only works with 2 servers. It only works with this sort of technology. I'm going to have to restart and start from the very beginning. That's the sort of things you want to work out in the design portion, the how portion. After you go to design, we jump down into the implementation. And everyone knows what implementation is. Implementation is you just build the thing. So you've done all the planning. Everyone's on the same page. Now you're going to divvy it up into, maybe you have teams. Maybe it's just a group of 3 people. Maybe it's just yourself and you're just going to divvy it up into certain tasks and milestones. But the implementation part is the building part. You're going to build the product. You're going to create what you have set out to create. And then the next step is verification. So with verification, what we're doing is something called testing. So we are trying to figure out a crucial question here. What we built, is it what we wanted to build? This is oftentimes a couple different things. So for example, is what we built what we wanted to build? Is what we built what our client wanted us to build? Is what we built working properly? Is it the input going in and it's creating the proper output? And this is why testing comes into play. And usually with testing, you need to know the requirements. You need to know what was it supposed to do. And then with testing, you can test against that. Does it do what it was supposed to do? So this is a very important step, and this is another one that's oftentimes sort of forgotten. If there's a time crunch, people are like, oh no, don't worry about testing. We'll just do some quick major tests and then we'll move on. And that can be a big problem because then you have those giant bugs in your program. Maybe they don't manifest themselves for a couple of years and then it leads to a giant data security breach. Or maybe it's just something very small over time. Maybe all the data going into the database is off by 1 and it can sort of skew your data and then it'll cost a whole lot later on in the maintenance phase, which is this phase right here, to end up fixing it. So verification and testing is important. And we'll cover some techniques on that and some of the ways that you should be testing. And then finally, what we have is we have maintenance. And this is that sort of that end cycle where you're going to be fixing bugs. You're also going to be sort of maybe even doing more testing, maybe implementing some other things, maybe redesigning things. Maintenance step is sort of the way this cycles back. A lot of times, if you're, for example, developing an additional feature, you would actually cycle all the way back to the requirements and then start this process over. But the maintenance cycle is typically just fixing bugs, making sure that like little adjustments to make it more in line with the requirements and to just keep it running, to make, do server updates and update this technology and that technology. So maintenance is important, and maintenance can be very, very sort of difficult if you don't go through all of these steps. So there could be a ton of bugs if you don't have all these. And especially if there's no documentation in this, so you didn't write anything down, you didn't actually have this whole plan written out, then it can be very difficult because you can't really bring in other programmers. It'll take them 6 months to learn the code base, etc., etc. But anyway, this is the top-down view of the typical software development cycle. Now, throughout the rest of the course, we're going to start breaking these down a little bit by a little bit, and then sort of deep diving into each one of these. And then looking at neat things like models, which are all like how you combine these different steps, the best way to do it. Do you do it like a V, where you sort of put some of these on each side of it? Do you do it, there's these things called Scrum and the waterfall method. We'll go over all of that. But software development cycle, really good to know, and you're going to be seeing it a whole lot.